Hello friends and welcome back. Today we are going to explore and discuss top 5 PostgreSQL extensions for application developers. And our rank is going to be unusual. We will start with the most obvious extensions and then go down to the least obvious extensions for those who build applications daily. Let's not waste a minute and do a deep dive. Alright, my fellow developers, I have created this application template skeleton that we'll be using to explore and play with various PostgreSQL extensions for developers. Now let me go ahead and open this template in Visual Studio Code. Those of you who use JavaScript or Node.js, you will recognize that this source code looks familiar, but if your primary programming language is Java, C#, Rust, or anything else, not a problem, my friend. Just create the same app in your preferred programming language. Now let's take a look at this index.js file contents. We are going to use a driver of Postgres for Node.js. It's already imported. And then this is how my database connection endpoint looks like. I'm going to connect to a Postgres instance in Temba, and I will explain you why within a minute. Then that's the port number, that's my database user, and I have some password. I don't want you to see this password, that's why this password is stored in this file, and I will be just reading the contents of this file. Also, we are going to connect securely to our cloud environment. That's why I'm going to use this certificate that was generated for me by Temba. Next, once we open this connection to the database, we will connect and then we will print some result, but there is no any result yet. Let's do this. I want to run the following request. And in this request, I want to get a list of all their extensions that are presently installed on my Postgres instance. And that's all we do. Let's run our application. As you can see, yes, I'm running Postgres with a bunch of extensions already. And why Temba? Why don't I run just an open source version of Postgres on my local laptop? There is a good reason. Because Postgres does have a bunch of extensions, and when you install a single extension, it's usually not a problem. But when you want to use multiple extensions for your project, then this process of the configuration and installation might be tedious. And Temba solved this problem for me. This is my free Temba instance running somewhere in the cloud. And if you go to the extensions, to the Explore tab, you will see that presently Temba supports over 200 different extensions. And when you want to enable any extension, you just install it, it gets added to your instance, and then you will be able to use it, just single-click experience. If I go to the Manage, you'll find a bunch of extensions that are already enabled and used by me, and we are going to explore these extensions. Okay, now let's start with our list of top 5 PostgreSQL extensions for application developers. And as I said, the rank is unusual. We will start with the most obvious extensions and go down to the least obvious ones. So number 5, the most obvious extension. Guess what? It's pgvector, and I have this pgvector extension already enabled for my instance in Temba. What the extension does, it turns Postgres into a vector database. With these extensions, you can store embeddings in Postgres and then perform vector similarity searches over your data. Just keep using Postgres for GenAI applications. Let's go to my application code and quickly see how this extension works in practice. What I created so far, I have a table that stores information about different movies. Every movie has a title, overview, and also the overview vector. This overview vector was generated for all of the movie overviews. I used an embedding model of OpenAI. So let me show you how the data looks like. I'm going to get 3 random movies from my database instance. And now you can see this long array of floating point numbers. What's that? This is this vector embedding that was generated for the following overview. This is the title of the movie. When you scroll up, you will find that every movie that I have in my database has this vector associated with the overview, and there is the title. Now, how can we build GenAI applications? Let's do this. Let's say that we want to support the following functionality. Some user wants to watch movies and we want Postgres to provide various movie recommendations based on the user prompt that's going to be passed into the following method. So once we execute this method, what's going to happen? We are going to open a connection with OpenAI using our developer key. And then we will take this user prompt, the ask of the user, and we will connect to the OpenAI embedding model to generate an embedding for the provided prompt. And we are using the same embedding model that was used for the overview vectors generation for our movies database. Once we have this embedding, we will perform the vector similarity search over the movies catalog that we store in Postgres. How does it work? Generally, I don't want to go deep into the details because I have on my channel dedicated videos about that, but generally, we are going to find the most similar movies for the provided user prompt, and then we are going to return them back to our application. So this is how it works. Now let's do this. I have this logic, and what we can do, execute this recommend movies method. I want to watch this movie long time ago in the galaxy far, far away. I guess that you know what the recommendation should be. Let's restart this application. Yeah, something is not defined, right? Because I forgot to import the following library into my project. That's all I need to do. Once this is done, let's restart. And this time we are getting these recommendations. As you can see, yeah, we've got a few recommendations. For instance, we can watch the episode 2 of Star Wars, then Empire Strikes Back, and also The Force Awakens. Wonderful. So this is pgvector, number 5, the most obvious extension for GenAI applications with Postgres. Let's move forward. Number 4, the next obvious extension from our list. In fact, that's not an individual extension, but a category of extensions. Those extensions let you create database functions or stored procedures in your favorite programming language. If you use Tempo, you will find those extensions under the category of procedural languages. And you can create those database functions in JavaScript, Java, Rust, or any other major programming language. As long as I am creating a Node.js application today, I'm going to use the PLV8 extension. So this extension lets me write their database logic in JavaScript, deploy this database logic to the database, and then run it from my application. Let's take a look how it works in practice. What I have in my project, I have the following database function. You always need to have this ceremony in the beginning when you create or replace function. The name of this function is going to be who's that? And down below in the body of this function, you will find the JavaScript code. This PLV8 extension lets us execute SQL statements over the database instance, but then you also can use any other standard JavaScript functions and operators. Let me do this. Let me copy this function, jumping back to my index.js file. First, let's clean our code sample. We no longer need to play with pgvector, removing this method. Instead, what we want to achieve right now, I have this application logic, and I want to make a call to the function that I'm about to create. The name of this function is who is that, okay? And they're printing the result. When I start this application right now, I'm not surprised that I see this exception because what? There is no any magic, there is no any free lunch. Yes, I've created this database function using JavaScript, but this function needs to be created and deployed on the database. It means that what we need to do, we need to connect to our database instance, and then we need to create this logic. Once it's created, you can quit the database and you can restart your application. And here you are getting this response. Yeah, that's our Postgres instance, and that's the version of my Postgres instance in Temba. What happens next? We are developers and we usually iterate on our application logic. If I decide to update this logic, then I would need to repeat the same process. I would need to change this logic here, then I will connect to the database, I will update this logic there, and then I will make a call to my database function. And this works, but it's not super developer friendly. It's very cool that I can create those database functions in JavaScript, but I'm not satisfied with the developer experience. Luckily, if you use JavaScript, then you can use another extension, another library for Postgres. It's called pgcompute. And with the pgcompute, what you can do, you can take JavaScript functions from your application logic, and you can automatically deploy them to the database, and then they will be executed by the pgv8 extension for you. Let's create an instance of this pgcompute object. We do it this way. And then we need to initialize pgcompute by passing the database client. Once this happens, we are ready to deploy our custom function. Let's do this. Let's create this function. Who is the boss? And the logic can be as follows. You certainly can use the pgv8 extension. Let's say the version. You can use pgv8, execute. And then we can also add the message. I'm the boss, Postgres. And finally, you need to return a JSON as a result. We will return the message and we will return the version. That's the logic. It looks like a casual logic as part of our application, but then we want to deploy this logic to the database and execute it. It's easy to do. Let's use pgcompute. We use the run method. We are passing the client, the database client connection, and then who is the boss. We are getting this result, and let's print this result. Hopefully I did not mess up and this application will work without issues. Wonderful. You see how the experience is different. What happened? pgcompute library, it took my function, JavaScript function, it connected to Postgres using the database connection. It created that function on the database automatically for us, and then we executed. This is the experience I love. And another beauty is, if you want to iterate on the implementation of this function, we can do this. For instance, I want to add some custom parameter to this function, like name. And I can say that I am the boss, and who are you? You can add this message too. I'm the boss, and we are passing its name, version, message to, something like that. So we generally change in this function. Then we want to execute the same function, but we also pass the name. My name is Dennis. Let's see if it works. I expect that pgcompute will detect that the function was updated. Excellent. You can see that if it was updated, we still return the same version, and that's the question, who are you? And that's the parameter Dennis, my name, that was passed to the function. This is how it works. So that was number 4, extensions that let you create database functions in your favorite programming language. And we explored pgv8 today. And if you're a JavaScript developer, you can also use pgcompute on the application end to create and execute those functions seamlessly. Okay, cool. Let's move forward. Number 3, the next obvious extension. And again, we are going to talk about a category of extensions. In particular, let's talk about foreign data wrappers. I'm going to the repository of Timber, and under the connectors, you will find a bunch of foreign data wrappers. What's the use case for us application developers? Let's say that you have some application logic, your application primarily works with Postgres, but then once in a while you need to pull data from another data source. That can be Mongo, ClickHouse, Oracle, MySQL, Kafka, or anything else that has a foreign data wrapper for Postgres. And instead of introducing a library or framework that would let you work with another system on your application layer, you can trust Postgres to do the job for you. For an example, if you want to pull data from files from Kafka, from JDBC, MySQL, Oracle, or anything else, you can use Postgres. Today, I'm not going to show how this works in practice. I want this to be your homework. Find a foreign data wrapper that looks cool or reasonable for your application and give it a try. In the meantime, we will move forward to the second extension, and this one is less known. Let's talk about pgmq. I already have pgmq enabled for my Tempo instance, and what this extension allows me to do, it lets me use Postgres as a lightweight message queue. If you don't want to introduce another message queue, you just want to have that basic lightweight message queue experience, then Postgres is an interesting choice. Let's see how we can use this extension in practice. Jumping back to my application logic. Let's clean our sample application. We've played enough with database functions. We no longer need pgcompute. Instead, we will be using pgmq, and you certainly can use pgmq using the SQL interface, but also if you're a JavaScript developer, the team that developed this extension introduced a special library. You need to import this library into your Node.js project this way, pgmq. The name of the library is pgmq.js. We are done. So once you initialize this pgmq object, you need to come up with the queue name. And after that, you can move forward. First, let's use pgmq create method to create our queue. And also, just in case I don't want to pollute my database as long as I'm playing, I will also drop the queue after this code sample gets executed. Let me quickly check that everything works. No, looks like I messed up with something. It said that it's already been declared. Yeah, did it twice. Restarting. And this time the application code logged perfectly well, meaning that we managed to create and drop this queue in Postgres. What's next? Let's send a few messages. Why not? I'm going to send... let's say 5, let's do 5 messages. And the interface is a little bit different. We need to send the message into my queue. And yeah, we need to pass an ID. And we can pass some name. Hello world, about this. Cool. Once we send these messages, let's also read them back. And for that, as one of the options, we can use the pop method. The pop method gets the message from the queue and removes it from the queue once it's read. Do this, just pop. And let's get this message. I want to print this message. Hopefully everything looks okay. Let's restart our application. You can see that we successfully placed several messages in the queue, and then we read all those messages back. So this is how you can use Postgres as a lightweight message queue. It's super easy, folks. Keep this in mind. That was the second extension, one of the least known ones. And now let's get to the final one, the least known extension, number 1. What's that mysterious number 1 least known extension of Postgres? Let's go to Timber to figure out. And this extension is called pganonymize. With that extension, you can anonymize sensitive or personal data that is stored in your database. What might be a use case? Let's say that you have production data set, and then you want to take a snapshot of this data set and use it for your pre-production testing or in your development cycles. And you want to hide some of the details for the sensitive or personal user data. And this is what that extension was designed for. Also, a quick note, that's not the only one extension in the Postgres ecosystem that can be used for the data anonymization. Another one is called PostgreSQL Anonymizer. It might be a little bit more advanced, and I'll let you pick the one that works best for you. But today I'm going to use this one. Before we can start using this extension from the application logic, we need to configure it. For that, I'm connecting to my Tempo instance of Postgres. And then I need to follow this step. I need to create a user role that will be granted restricted access to my database, and pganonymize will be anonymizing a subset of the data for that particular user. So let's take a look at the step-by-step flow. First, we need to load the pganonymize extension. Next, I'm creating the new user. The name of the user is test user, and that's the password. This user will have a very restricted access to my database, but I allow this user to connect to my Postgres database. Okay, so the error says that that user already exists. I played with this extension, but on your end, this method will be executed successfully. Next, we need to create this security label for pg-anonymized extension for our test user, meaning that the data needs to be anonymized for this user. What happens next? We are altering this user role. Every time anybody connects to the database using this user, we are going to preload the pg-anonymized extension. The role is created. And next, we are ready to define those data anonymization rules for our created user. I will be playing with the following sample table. It's called user account. Yeah, the data is not readable. Let's do this and repeat the request. You can see that in that table we store information such as user ID. Then we have the user email, the user password, and the username. And suppose that I don't want this sensitive information to be visible to my user that I've just created. How do we do this? Easy. All we need to do is we are defining the security labels for our pg-anonymized extension, and we are saying that for this column, public user account email, please anonymize the data the following way. And also we are anonymizing the password column, right? We are just replacing the contents of the password with the strong password string text. And then we are also anonymizing the full name of our users. So that's what we do. Everything is created. Now we want to see how everything works from the application standpoint. Okay, we need to do this final cleanup of our application logic. We no longer use pgmq, even though I love this extension. What we need to do instead, we will be connecting to our database using our test user account and the password. That's it. Let's get this result. I'm going to use client query, and I want to get, let's get all the rows from our user account table. And then I'm just printing those rows. Now, fingers crossed. Let's see how it works. Excellent. Now the application is ready. We application developers were given this new account, and for that user account, the data will be anonymized by the pg-anonymized extension. And this is what we see on the application end. Wonderful. Congratulations. How do you like this, my friend? Isn't it cool? Today we explored top 5 PostgreSQL extensions for application developers, and we started with the most obvious one, pgvector, that is widely used to build GenAI apps on Postgres. And then we went down to the least known extension, pg-anonymize, that you can use for the data anonymization needs. So hope you enjoyed this video, and in the description you will find a link to a step-by-step guide if you would like to reproduce all the steps on your end. So have fun mastering databases, my friend, and stay tuned for new videos. Bye bye now.